from Rajaram Bapu Institute of Technology, Rajaram Nagar. I am Pranav and I have with me Dilip Kumar Desai.
Hello friends.
And today we are going to present tutorial on simple steps to make line follower robot. I hope it helps you. So now, what is line follower robot? It is a machine that follows a line, either a black line on white surface or white line on black surface. For beginners, it is usually their first robot to play with. In this tutorial, we will teach you to make the line follower robot moving on the line with a type of feedback mechanism. It's the most basic example of adding small intelligence to a robot, but it's actually the designer's intelligence. The robot must be able to detect particular line and keep following it. And for special situations such as crossovers where the robot can have more than one path which can be followed, predefined path must be followed by the robot. Now components. We need sensor which are IR based digital sensors, then controller Atmega 328, then motor driver IC L293D, then we need two motors, then one battery of 9 volts, then Arduino software, chassis, wheel, caster wheel and wires. So first one is chassis. It's basically the frame of robot on which motors and wheels are mounted, and all the circuitry part is also placed on it. Now sensors. An array of sensor is used to detect the line. Based on the status of sensors, special circuit or controller decides the position of line and also the required direction of motion required to follow the line. Sensors are required to detect position of the line to be followed with respect to robot's position. Most widely used sensors for line follower robots are photosensors. They are based on the basic observation that the white surface reflects the light and the black surface absorbs it. IR light is emitted from emitter. This emitted light strikes the surface and gets reflected back. If the surface is white, more intensity of light gets reflected, and for black surface, very less intensity of light is reflected. Photodetector is used to detect the intensity of light reflected. The corresponding analog voltage is induced based on the intensity of reflected light. This voltage is compared with fixed reference voltage in comparator circuit, and hence it is converted into logic 0 and logic 1, which can be used by controller. Now, how sensor works. Here consider three cases A, B, C respectively, where in case A you can see that the sensor on leftmost is on black line producing output low, and remaining two sensors produces output high as they are on the white surface. So controller will analyze the output and rotate the robot to its left. Similarly, in second case you can see the sensor on right side is on black line. So again controller will analyze the output produced by sensor and rotate robot to its right. And in third case, the middle sensor is on black line, so robot will follow its predefined path, that is straight path.
Next part is microcontroller. Microcontroller is most important component of line follower robot. Here we are using Atmega 328 controller. Controller is used to interface between sensor and motors. The Atmega 328 is a single chip microcontroller created by Atmel. It is 8-bit AVR RISC-based microcontroller, combines 32 kilobyte flash memory, 2 kilobytes RAM, 32 general purpose registers and 28 pins. It works on operating frequency up to 20 MHz. So when sensor sends output, microcontroller combines or compares output of three sensors and according to the condition, it sends high or low value to motor driver IC. Now, the next component is L293D motor driver IC. This IC is used to drive DC motor rotating in either direction. It is 16-pin IC which can control a set of two DC motors simultaneously. The L293D uses 5V for its own power and external power source is needed to drive the motors. which can be up to 36 volt and draw current up to 600 milliampere. There are two enable pins on L293D, pin 1 and pin 9. To drive the corresponding motor, pin 1 and pin 9 need to be set to high. If either pin 1 or pin 9 goes low, then the motor in the corresponding section will suspend working. Now there are four input pins for the L293D for left side motor and right side motor. Pin 2 and pin 7 on the left and pin 15 and pin 10 on the right as shown in pin diagram. Left input pin regulates the rotation of motor connected on left side and right input for motor on the right hand side. Information about component required. Let's move towards the code. See the program. Here three pins are to be set as input pins and four pins are to be set as output pins. From those four pins, pin 8 and pin 9 are used for driving left motor and pin 6 and pin 7 are used for driving right motor. Now let us see the condition in which if pin number 8 is high and pin number 9 is low, then left motor will move in the forward direction. If both 8 and 9 are low or high, left motor will stop. Similarly, if pin number 6 is high and pin number 7 is low, then right motor moves in forward direction. And if both 6 and 7 is high or low, right motor will stop. So in program we have to declare three variables R, L, C. R for right, L for left and C for central sensor. Here we configure pins of controllers, that is pin 5 for right sensor, pin 3 for left sensor and pin number 4 for central sensors. Now we check sensors outputs. If right sensor gets high output, left sensor gives high output and middle sensor gives low output, it means that central sensor is on black path. So we have to drive both motor in forward direction. So we give 8 as high, 9 as low and pin number 6 and as high and pin number 7 as low. If this condition is failed, controller will check the next loop. In next loop, if right sensor gives high output, left sensor gives low output and center sensor gives high output, then we need only right motor to rotate and left motor to stop so that our controller will move towards left side direction. For this, we use pin number 6 as high and pin number 7 as low and pin number 8 and 9 as high. If this also fails, then we check the next loop. Next loop, right sensor gives low output, left sensor gives high output and center sensor gives high output. Then we need only left motor to rotate and right motor to stop so that our robot will move in the right side direction. For this, we use pin number 6 and 7 as high and pin number 8 as high and pin number 9 as low. If all these conditions are failed, it means that our robot, our three sensor gets the high output. So when all sensor gets high output, we need to stop robot. So we give high value for all 6, 7, 8, 9 pins. This is all about our three sensors, robots having three sensors.
Let's see the block diagram. The first block is sensor array. We use array of sensors to detect the reflected light back from the surface. Then we give this signal as input to controller for further actions. Now, next block is microcontroller. Controller compares the signal from sensors to give directions to motor driver IC. Then third block is motor driver IC. Motor driver IC provides appropriate current and voltage to motors for driving. And in this way, motors control the wheels so that robot will follow the correct path. Now, we have one stereotype of line follow robot. We will show you how it works. This is all about a line follower robot. We hope these steps will help you to build your line follower robot. Thank you. Thank you for watching this video.